Hello everyone, I welcome you in the session of Expansion of Functions Part 4. This is SNikam, Assistant Professor, Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. At the end of this session, student can able to solve examples of limits by using indeterminate forms. Friends, before we proceed or start the session directly, please brush up the things and solve this example. Limit x tends to 0, log to the base x into sin x. In order to do so, please pause your video. I hope you have done, so that we'll solve it with the help of an identity of logarithm. Log of b to the base a can be written as log b upon log a. So likewise, we'll write down limit x tends to 0 log to the base x into sin x as limit x tends to 0 numerator log of sin x divided by denominator log x. Now if you put x equal to 0 in the respective places, then we'll get the format minus infinity by minus infinity. So which is an indeterminate form, and therefore by using L'Hospital's rule, it is equal to limit x tends to 0 bracket 1 upon sin x into cos x whole divided by 1 by x. Therefore, we will simplify it and write down it as limit x tends to 0 bracket 1 upon sin x upon x into limit x tends to 0 of cos x. Now we know this identity from our 12th standard and write down this limit to be 1. Cos 0 is 1 and hence the product is equal to 1. Now friends, 0 by 0, infinity by infinity, 0 into infinity, 0 raised to 0, infinity raised to 0, 1 raised to infinity and infinity minus infinity. These are the so-called indeterminate forms. One can apply L'Hospital's rule directly to the forms 0 by 0 and infinity by infinity. This is we have seen in earlier video. Now it is simple to translate 0 into infinity into 0 upon 1 by infinity or into infinity upon 1 by 0 form. For example, one can write limit x tends to infinity x into e raised to minus x as limit x tends to infinity x upon e raised to x, which is infinity by infinity indeterminate form, or limit x tends to infinity e raised to minus x divided by 1 by x, which is indeterminate form 0 by 0. Now let us see the forms 0 into infinity. We will suppose that limit x tends to infinity f of x to be 0 and limit x tends to infinity g of x to be infinity. Then we will have that limit x tends to infinity f of x into g of x is equal to 0 into infinity. To solve this type of indeterminate form, we will do a simple step. Limit x tends to infinity f of x into g of x is equal to either 1 upon f of x into g of x, which is g of x divided by 1 by f of x, which is plus or minus infinity divided by plus or minus infinity, and we will solve the limit. Solve an example so that we will get this concept. Limit x tends to infinity x square into e raised to minus x. Now substitute the limit directly and look at the form. This is an indeterminate form 0 into infinity, as this x square is infinity and e raised to minus infinity is 0. Now let us rewrite it as limit x tends to infinity x square e raised to minus x is equal to limit x tends to infinity x square upon e raised to x. Now this is infinity by infinity form, which is equal to limit x tends to infinity, apply L'Hospital's rule to this indeterminate form. Numerator derivative is 2x, denominator derivative is e raised to x. That is equal to, now if you put x equal to infinity directly, again it's a infinity by infinity form. It's an indeterminate form. So apply L'Hospital rule, that is equal to limit x tends to infinity, derivative of numerator is 2 and that of denominator is e raised to x. So that applying limit x tends to infinity to the term 2 by e raised to x, we'll get it as 2 by infinity and that is equal to 0. Now let's solve one more example. Limit x tends to 0, sin x into log x. This is an indeterminate form, 0 into minus infinity, because sin 0 is 0 and log 0 is minus infinity. Rewrite it as limit x tends to 0 sin x into log x is equal to limit x tends to 0 log x whole divided by 1 upon sin x, that is minus infinity by infinity form. 1 upon sin x can be written as cosec x. Now as it is an indeterminate form, infinity by infinity, so let us apply L'Hospital rule and take differentiation of numerator and denominator in the next term, so that we will get the term is equal to derivative of numerator log x ka derivative 1 by x whole divided by derivative of denominator is minus cosec x into cot x. Therefore, let us rewrite cosec x as 1 upon sin x and cot x as 1 upon tan x, so that it will give us limit x tends to 0 minus numerator sin x into tan x divided by x. Substitute the limit x tends to 0 so that numerator represents 0 and denominator also, which is a 0 by 0 indeterminate form. So applying L'Hospital's rule, it is equal to limit x tends to 0 minus sign outside the bracket. Apply u into v rule for differentiation. So tan x as it is, derivative of sin x is cos x, plus sin x as it is, derivative of tan x is sec square x whole divided by 1. Now applying limit x tends to 0 in these terms, we have cos 0 is 1 but tan 0 is 0, so first term goes to 0, plus in the second term we have a sin term, sin 0 is 0. So 0 plus 0 is 0. Hence we have got the limit as 0. Now let's move to the next form, infinity minus infinity. The form infinity minus infinity is indeterminate. Again, the general strategy for computing limits of this form is to convert to an indeterminate quotient, 0 by 0 or infinity by infinity. Example number 1. Compute limit x tends to infinity square root of bracket x square plus 3x plus 7 minus x. Solution. Multiply by conjugate to obtain. Now this given term as it is, to this term we will multiply it and divide it by its conjugate, that is under root of x square plus 3x plus 7 plus x. After doing so, we will simplify it as limit x tends to infinity, numerator x square plus 3x plus 7 minus x square whole divided by square root of x square plus 3x plus 7 plus x. That is equal to limit x tends to infinity, 3x plus 7 whole divided by square root of x square plus 3x plus 7 plus x. Therefore, limit x tends to infinity, taking x common from numerator as well as denominator, we will solve it as numerator 3 plus 7 by x, denominator x common in bracket under root of 1 plus 3 by x plus 7 by x square bracket complete plus 1. So cancelling out x and putting limit x equal to infinity, we get 3 upon under root 1 plus 1, which is 3 by 2 simply. For creation of this video, I have referred a text of Applied Mathematics by N.P. Bali, Ashok Saxena and S.N. Iyengar. Thank you so much for watching this video and have a happy learning.